All right. So, welcome back everyone, Friday. Today we're going to work through SAT3, which is discrete random variables. So you might remember term 1, we dedicated all to calculus. We did the rules and then the applications. We've covered both of those. And then we sort of take a break from calculus and we do just discrete random variables. So this is your binomial distribution and discrete probability distributions. So we have a summary sheet here that summarizes sort of the key formulas from the textbook and so forth. We're going to draw on those today as we answer these questions together. So I think we'll just get straight into it. Most of it should come back to us pretty clearly. And yeah, let's go for it. So we've got revision questions here. We have a policeman is inspecting the safety of tyres on cars passing through a checkpoint. The number of tyres which need to be replaced for each car follows the following distribution. So if you think cars either have 0, 1, 2, 3 or 4 tyres, and so then the probability that you need 0 tyres replaced is 0.68. Most cars driving past are safe, and we have this is the probability of the event occurring. And then we've got a number of other probabilities filled in here. We've got 0.2, we've got 0.06, we've got K, and we've got 0.02. Part A says find the value of K. So the value of K, we know that the sum of all probable events must add to 1 for it to be a valid probability distribution. So when we add up all of these together, it has to equal 1. So what have we got? 0.88, 0.94, 0.96. Plus K is 1, so we get K is 0.04. Okay, part B says find the mode of the distribution. Well, the mode is the event with the highest probability, so the mode is 0. And part C says what's the probability of X being larger than 1? So this is discrete variables, and if we're talking about X being larger than 1, that means not including 1, so it's event 2 plus 3 plus 4. Okay, so we've got 0.06 plus 0.04, 0.1 plus 0.02. We have 0.12. Very good. So that's a good recap of probability density functions. So that's sort of 7C point 1. Then we have 7C.2 where we learn about the mean. All right, so we have, this is big question 2. The mean of a probability density function, we also call the expected value, and that's just each event multiplied by its probability added together. That's the formula for the mean. And so we have this distribution here about Ernie going fishing. He catches 0, 1, 2 or 3 fishes. And we have the probabilities of those events here, 0.17, 0.28, 0.36 and 0.19. So events and probabilities of those events. Now to calculate the mean, okay, the mean of this distribution on average, how many fish do we expect him to catch? Each event multiplied by its probability added together. So we're going to have 0 times 0.17, 1 times 0.28, 2 times 0.36, and 3 times 0.19. All right, add all that together. So what are we going to have? 0.28 plus, no, that's 0.36, so that'll be 0.72 plus, and that'll be 0.38. So that takes us to 1.38 fishes.
The last one would be what, 0.57?
Oh, sorry, it's 2 times 0.1, 3 times 0.19. Yeah, thank you. So 1.57 fish. All right, so that's question 2, and then for question 3, we have find the mean, median, mode, and standard deviation of this distribution. And for this one, let's use our calculator, because most of the time you will use your calculator. However, occasionally you're required to show things manually. All of those calculations you can do manually. Let's pull our calculator out and refresh ourselves on those skills. So we're going into statistics mode. And what we're going to do is we're going to enter the data in both columns. So we have the events in the left column. So I've got 0, 1, 2, 3 in the left column, list 1. And then the corresponding probabilities in the right column. Excuse me, I've got too many events there. There's no event 0. The events are 1, 2, 3, and the probabilities are 0.3, 0.4, 0.3. Okay. So what we're going to do to bring up all of the statistical analysis is we'll go calc, and let's just talk about our calculator settings. Now I'm pretty sure it's either in this book or on the OneDrive. I might highlight a document to you today. I have a document about calculator settings. Okay, so I'm going to highlight that to you today. But what we'll do here, if we just go check out settings, what we want when we're doing a probability distribution, we want calc 1 there and the settings. We want it to be list 1 against list 2. All right, that's what's going to bring up that for us. So if we press calc and check your settings, so 1 var x list should say list 1, and 1 var frequency should say list 2. That's going to bring up the statistical probabilities for a probability density distribution. All right, so I evaluate that. And we've got all of our properties. So we have the mean is 2, okay? Now, x bar means sample mean, so it's assuming a sample, that's fine, just means sample mean. We've got the median, all right, tells us the median is 2, so I'm just scrolling down. The mode, it says there are 2 modes. It says the mode is 2 as well. Mode is 2. What else did we need? The standard deviation, which is, now you'll notice there's 2. We've got sigma x and sx. Now, there is a slight difference between these, okay? The formula for both is in your textbook. Remember, sigma is for a population, S is for a sample. Now, what we have here, it's not a sample, it is the population probability distribution. So we're going to use the sigma value we're presented with, which is 0.775. Sorry, I've written it in the wrong spot. Sigma is 0.775. All right, so all of that's there. That's our calculator skills. All right, so that's the first one, part 7C. It's a big refresher of probability distributions. In there, we assess things like fair games and so forth. Okay, then in question 4, what we might do is we'll have a look at question 4. So we have Dominic is a door-to-door salesman. Each day he earns $100 plus 25 for each sale made. From previous experience, Dominic knows that the number of sales made each day follows this distribution. So we have number of sales, and we've got 0, 1, 2, 3, 4, 5 sales, and then the probability of that many sales occurring. We have 0.17, 0.25, 0.3, 0.15, 0.1, 0.03. Okay, so there's our distribution, that's all good. Part A says find E of x. So this is the expected value of the distribution. The mean, now the fastest way to do that is probably typing it into your calculator. They're probably about the same speed really, but I'm just going to type it in my calculator so that I don't make a mistake when trying to evaluate it like I just did before, trying to evaluate it manually. 3, 4, 5. And we've got 0.17, 0.25, 0.3. Alright, I've got the mean is 1.85. So for discrete variables, we use both of these interchangeably. Mean and E of x mean the same thing. Alright. So that's A part 1. Now I'll just talk about how you can do the other 2 parts rather than evaluating. The standard deviation we can access from our calculator, and the variance is just the standard deviation squared. Okay, so we can access those quite easily. Then we have, suppose Y is the amount of money Dominic earns in dollars per day. Write Y in terms of X. So this is given to us in the second sentence of this question. Each day he earns $100 plus 25 for each sale. So if Y is Dominic's money, it's going to be $100 plus 25 for each sale. And we have the variable X is the number of sales that are made. Okay, and so then what we're doing is we're making a link between these two variables. It says, hence find E of Y. So I'll just highlight where that occurs to you. We have 7E, properties of AX plus B, and we have this formula here. We have E of AX plus B, sorry, that's capital E. The expected value of AX plus B is equal to A times E of X plus B. Alright, so we're asked, find the expected value of Y, where Y is some linear relationship involving X. Alright, so what we're going to do is we're going to go, what corresponds with A, what corresponds with B? Well, in this circumstance, A is 25, it's the coefficient of X, and B is 100. And so what we're going to evaluate then is 25 times the expected value of X, 1.85, plus 100. Alright, so what's that going to be? Just under 150. $146.25. Okay, now if we're going to interpret that, well, X is the amount of sales we expect him to make on average. Y is the amount of money he earns on average. So the expected amount of money he's going to earn per day, $146 per day. Okay, 2 to go. We have consider the spinner alongside. Let X equal 1 if the outcome is red and X equals 0 if the outcome is white. Explain why X is a Bernoulli random variable. Okay, so for a Bernoulli distribution, we have two properties. There is one trial, and we have two outcomes denoted by success is 1, failure is 0. So that's what a Bernoulli variable is. Part B, find the mean of X and the standard deviation of X. So we'll flip back to our formula sheet 7F. The mean is just P, and the standard deviation is the square root of PQ. Is that correct? For a Bernoulli distribution. Yep. Okay, so in this circumstance, right, we have events 0 and 1. That's what we've defined them as. We have success and failure, and X is 0 if the outcome is white, and X is 1 if the outcome is red. And if we're spinning it and it's a fair spinner, we expect it to land on 1 3/4 of the time, and we expect it to land on 0 1/4 of the time. Alright, now P in this circumstance is the probability of success, and Q is the probability of failure. So the mean is 3 on 4, and the standard deviation is the square root of 3 on 4 times 1 on 4, root 3 on 4. Alright, so that'll be 3 on 16, and we can square root the 4 separate. Alright, so that's 5. Okay, number 6, then we get into a binomial distribution. Records show that 6% of the items assembled on a production line are faulty. A random sample of 12 items is selected without replacement. Find the probability that none will be faulty. So I'm going to draw on 3 processes here. Okay, I'm going to answer this in 3 ways, just to really emphasize binomial distribution. The first is this formula. Alright, this is we have the probability of having k successes is equal to the number of ways that it can be arranged, k successes, the probability of successes to the number of successes, the probability of failure to the number of failures. Okay, so in our circumstance here, we have 6% are faulty. What's the probability that we have no faults? Okay, so let's say in this circumstance, if it's faulty, let's define that as a success, just doesn't really matter. We find a faulty one where we have a success, and so if we have no successes, we have no faulty ones, that means we have no successes. So here's how we would answer part A. We have 12 trials. We're talking about no successes. The probability of a success, that is a faulty mechanism, 0.06 to the number of successes. The probability of a failure, 0.94, it's just the inverse probability to the power of the number of failures. Okay, that's binomial distribution formula. That's the first way to calculate it. The second way is BPD. All right, the mode on the calculator. So BPD, and we put in X and P. That's the syntax we use. And so in this circumstance, we have number of successes, number of trials, probability of success, 0 successes, 12 trials, and the probability of success is 0.06. This calculation will give us the same value as this one. Okay, and the third way that we can evaluate this is that if we have no successes, that means we had all failures. That every time we picked a piece of an item off the assembly line, it was faulty. So it was not faulty. And so the probability of picking the first one off and it not being faulty is 0.94. And then getting the next one off and it not being faulty is 0.94. And then the next one off and it not being... So this just goes on until we have all 12 items. 0.94 times itself 12 times. And you might be able to start to see a relationship between this calculation and this one. Okay, 0.06 to the power of 0, that's 1. C12 0, that's 1. And so when you evaluate this, you're just left with that. So they're the same calculation. Okay, let's evaluate this anyway and just try and draw out all of those procedures we can use to answer it. So whichever method you prefer, 0.94 to the 12 is probably easiest to type in at this stage. We've got 0.47. 59, 0.476. So if we're randomly selecting 12 items, the probability that none are faulty is under 50%. Okay, next one we have, what about at most one being faulty? At most having one item faulty. So what this means, this is the probability of having 0 items faulty or 1 item faulty. Okay? So there's 2 ways we can think about it. It's the probability of having 0 faults plus the probability of having 1 fault. Or we can do a BCD calculation. And the BCD goes, what are the boundaries over which we're saying the event can occur? So we're talking about between 0 faults and 1 fault out of 12 trials, and the probability of a fault is 0.06. All right, BCD calculation is the fastest way to do this one. You could do it separately in that you can do both of these as BPD and add them together, but that's all BCD is a cumulative sum of binomial distributions. So let's do that quickly. And you can do it in your run mat, you can do it in your calculator mode, whatever you prefer. So we're going from 0 to 1 of 12.06. And I've got 0.8404. 0.840. Alright, so that's B. On to C. What about we have if at least 2 are faulty? At least 2 are faulty. So this is for 6C. So at least 2 means 2 or more. So BCD, 2 or more, all the way up to 12 being faulty, out of 12 trials, and the probability of being faulty 0.06. So another BCD calculation there. .1595. And then we have less than 4. Okay, less than 4. So when you think about how many can be faulty, remember we're talking about discrete variables, all the way up to 12. You could have 0 being faulty, you could have 12 being faulty, all of them being faulty, and we're saying less than 4. So that means between 0 and 3. Alright, so BCD, 0 to 3 out of 12, and the probability of being faulty is 0.06. Now you have to be careful with these questions because every now and then, like all of these ones ask us about what's the probability of it being faulty, but occasionally they will ask the inverse event, where they'll say, what's the probability of it not being faulty? Okay, what's the probability of having at least 7 that aren't faulty? So you have to read them carefully. Alright, so we'll evaluate this quickly, 0 to 3, and we've got 0.9956. And so this is useful, 0.9956, 0.996. All right. So so we'll stop there. I've got the 2024 test we did on discrete variables, so I'll pass those out. Also pull my laptop up and I'll show you this calculated instructions document so you can have a familiarise yourself with it. Other than that,